Hey, what's happening, guys? It is Christmas morning 2023. Of course, you're not seeing this today. You're seeing this, a week or two later. But today I wanted to show you something really cool, and that's this guy right here. This is the Arduino Uno R4 Wi-Fi, and this is a really cool board. Check this out. It is the exact same form factor as its older brother, the original Uno R3. That, I don't know how many of these boards are in existence, but millions. And they're based on, the AVR AT328P microprocessor from Atmel. And this is a great 8-bit processor. It is, driven millions of projects all over the globe. But, time moves on. Even though Arduino is not going to discontinue this board nor support for it, there are improvements, iterations, I guess you could say. And there have been other iterations in the past few years. I've played with a couple of them. But they kind of take you away from the Arduino architecture. And then if you're going to do that, then you might as well get something more powerful anyway. That's what I like about this. This is doesn't change the Arduino architecture at all. It simply adds to it. Unplug it here. And let's start talking about what makes this one so special. And let's start with the processor. Even though, they look similar, they are in fact quite different. So here is one of the processors. It'll focus. Are you going to focus? There we go. This is the Renesas, R-E-N-E-S-A-S. This is the RA4 M1. It is an ARM Cortex M4 processor. It's a 32-bit, microprocessor. But look, that's not all. There's an ESP32S3 on there as well. So you actually have two separate processors. And that's why, this particular board is the Uno R4 Wi-Fi. They also have one that's called the Uno R4 Minima. And I don't believe it has the ESP32, and it definitely doesn't have the LED matrix. But I mean, that is just a huge boost right there. A 32-bit microprocessor is running at a 48 megahertz. That's pretty doggone cool. So what else? Well, we have expanded memory and a faster clock. The R4 has I lost my place in my notes. Can you believe that? Hang on. Yes, I have notes, but nothing is scripted. You couldn't tell. Anyway, the memory in the RA4 M1 is 256K of flash memory and 32 kilobytes of RAM. Then in the ESP32, you have 384 kilobytes of ROM and 512 kilobytes of SRAM. Again, I said that we have the 48 megahertz clock for the Renesas microprocessor, and we can run the ESP32 up to 248 or 240 megahertz as well, which is really cool. This is a 5-volt system, just like the old Arduino, but you got to keep in mind that the ESP32 is not. It is a 3.3 volt system. Now, everything going on here, there's level shifters built into the board. You don't have to worry about it. But you can program the ESP32 separately on this separate pin header over here. But, make sure that you do not give it 5 volts. They are not 5 volt tolerant, and that will be it. All right. So now we hit on the changes in the processor, going from one 8-bit processor to two 32-bit systems on one board is pretty incredible. We talked about this being 5 volt tolerant. It does use in USB Type-C connector there. which I like better than these janky old Type A, or the printer type. This is just much nicer, and I am trying to get all my stuff migrated over to USB-C. Now, like we said in the beginning, they look the same, they're shaped the same, they are electrically and physically compatible. Any signals you expect to see on these pins, you will find on these pins. They're made to be compatible electrically and physically. However, like I said, we've changed from the AVR microprocessor to the ARM processor here. So anything that is specific to the AVR microsystem is probably not going to work out unless you make some changes to it. What does that mean? Well, that means that any shield that works with the R3 and just uses, the Arduino bastardized C++ programming language will be just fine. But if we're talking, specifically addressing the AVR microsystem, then that shield's not going to work on here. And that's going to have to do with a lot of libraries as well. Any libraries that, are doing machine level communication are going to have a problem because you're going to a different system. But while taking away some of those libraries, and don't worry, they're going to come back. The people that wrote the original libraries, like, Lady Ada, for instance, they're going to write them for this too. They're just going to port them over because I really think this is going to super take off. This has so much peripheral tangent items built onto the board that just makes it really cool. Like we've already talked about, you have Wi-Fi and Bluetooth on here for wireless communications. We also have a what's called a quick connector, QWIIC connector. Well, let's talk about what else is built into this board that just takes it from this bare bones system and brings it up not quite to Raspberry Pi levels, but awfully close. So with the R3, communications wise, you had a couple options. You have a UART, serial communications right there. Also, you have over here on A4, A5, and on some Arduinos, they're broken out up here as well. You have I2C connections, SDL and SDA. And then you have your SPI connections up here, your serial peripheral interface pins, 13 through 9. And that gave you a lot of great ways to communicate. Well, they've taken all that and included it here, and then they bumped it up even more. One thing this is really lacking is an analog output. This is a purely digital board. What that means is it only understands on and off, 5 volts and 0 volts. So anything we want to do with an analog output to the Arduino either needs an external DAC, a digital to analog converter, or it is going to require some sort of fudging, like using a lookup table to simulate an analog output, or using PWM to simulate an analog output. Well, the new R4 has a built-in 12-bit DAC. You can find it on analog pin A0. Now, along with the DAC, built into the Renesas ARM processor are 3 separate op amps, and, wait for it, they have broken one of them out. It is on, I believe, I'd have to look this up to be sure, but it's on the analog pins. I think it is 1, 2, and 3, or it might be 2, 3, and 4. Either, probably 1, 2, and 3, because 4 and 5 are your I2C pins, and A is your, or 0 is your DAC output. So you have your inverting, your non-inverting, and your output pins there. So what am I saying? Well, I'm saying we now have actual analog output and an op amp. You can start doing audio things with this, which now takes us into the realm of, the teensy and things along those lines. In addition, they have also put on a CAN bus. So we have the CAN bus on here as well, which is, if you're unfamiliar with it, you'll find CAN in modern vehicles. It is a differential bus system. You have the positive signal on one wire and the negative signal on another wire. Think about it, it's almost like a balanced audio line, really. So that's super cool. And we also have HID, Human Interface Device. That was only available on the Arduino Pro Micro and I think like the Leonardo before. Well, it's built into here now. So now this guy can emulate the mouse or the keyboard on your computer. And of course, let me turn off some of the lighting going on here. I mean, you surely didn't miss this giant LED matrix right here, right? I mean, it kind of jumps out and screams at you. And there's my notes. And I don't know how well you're going to be able to see this in here. There we go. It is currently playing Conway's Game of Life. So this is a 12 by 8 LED matrix, and Arduino has included a library to use this, and we'll talk about that here in a little bit when we go talk about how to program this and use it on the computer. But hey, how cool is that? The Game of Life. So now you can put animations on here, just about anything you want, including a clock, because yes, this has a real-time clock built into it. And let me get some more light here. Watch your eyes. Where are the clocks? Okay, so we have a... Oh, we need more light even still. Okay. So we have this VRTC pin here. This is to provide external power to keep the real-time clock alive. And then we have this off pin here, which allows us to, remotely turn the power to the microprocessors on and off, but keep the real-time clock alive. That's pretty cool. Okay, guys, we are into the Arduino IDE, and this is the 2.21 version. Although you can use the R4 Wi-Fi with the older version, the 1.8.6 version, which is what I use. But this has the board built in, so I wanted to show you that. And also, I'm using my new Beta 58 microphone with a nice little pop filter on a gooseneck arm, trying to be all professional. So hopefully you got some better audio today. So anyway, here we are. We are in the Arduino IDE 2.2, and you can see we have a list of our boards there, and this one is on COM24, but it behaves just like all the others. Here you can go down here to board manager, and you can see all of your boards that you have installed here. The AVR boards, that takes care of your R3 and your Nano and Pro Micro and Pro Mini and Mega and all that stuff. Then when we get to the R4, that is Arduino Renesas. It's a Renesas board. I'm not sure which one of these it is, or Tenta. Yeah, here it is. Arduino R4 boards right here. Boards include the Arduino R4 Wi-Fi and also the Minima, I believe, are both involved in that. So with these new boards in the new IDE, we also have some new examples here. And if you come over here, you can see examples for Arduino Uno R4 Wi-Fi. And these examples are really important because they're going to teach you how to use the new additions to the board that you're not used to from the R3. For instance, here for analog wave, we have the digital to analog converter stuff. So you see all of that. Then we have the CAN bus stuff. We have the Arduino FreeRTOS. That's real-time operating system, EEPROM. LED matrix, which is one of the key selling points on this board. You're really going to need to know how to program that matrix. So if we come over here and we say LED matrix intro, and we'll bring up this file. So this is the default sketch that comes with the board, as it's telling you here. And we can come down here and it says, we need to include the matrix library, obviously, or we're not going to be able to talk to it. We also have an animation library that does that. But you see here we have matrix. We're talking to the matrix here. Load sequence, and then the frames we want to load, and the matrix begin. Now, I haven't played with this a lot, but you can see the matrix commands just work by using the matrix. It's really kind of intuitive. But if you don't know the syntax, it's going to be difficult. So what else do we have here? We have things for the op amp. So we'll bring that up and take a quick look at it. So it's pretty simple. Delay, serial monitor delay, activate op amp channel 0. So we say op amp begin, op amp speed, high speed, failed to start. We have a Boolean constant is running, op amp is running, serial print op amp is running on channel 0, or op amp is not running. So how do we do it? I guess we say op amp begin. Like I said, I need to learn these just like you do. So that's the op amp. We have over the air update. We have RTC. That's our real-time clock. We have SD card reading. We have software serial stuff, watchdog, and we have all of our Wi-Fi stuff. So all of this is here. It's really simple to use. For instance, there's one in here. So I can find it. This is for the real-time clock. Okay, so what I've done is I have pulled up this little sketch here that is going to read the time off the computer when we upload the sketch and put it into the real-time clock. So you can see it says, we need to include the real-time clock. Then we're just going to do some string conversions here. We're going to come down here, real-time clock time, current time. So it is going to get a compilation timestamp in the new format, and is going to convert it, and it is going to print it out onto the serial port. So let's ship this out. It's compiling the sketch. Done compiling. It's uploading. Done in 3.53 seconds. And if we go to the serial monitor, we don't see anything. Shouldn't it be printing something on the serial monitor? $9,600. We're at $9,600. Why is it printing an A? Let's try and reset the board. Ah, there we go. So now we have our date and our time. Although it would look better with a 08 in there, but that's okay. And that's the alarm thing going off, telling us that we have an alarm. All right, so now let's take this and do something with it. Okay, so if you saw the short I uploaded the other day that showed the little clock running, this is the sketch for the clock. I'm not going to go into how it all works here, but basically it's doing kind of the same thing. We're grabbing the time from the real-time clock and we're displaying it on the LED matrix. So let's ship that out. And in just a second here, once it starts uploading, yep, there's our upload blinking. And it's done, and now we have the time showing. So it is now 9:11. Is that correct? Let's get the serial monitor up here. Oh, that's not going to work because I changed it. That's all right. But you get the idea, right? So guys, there is a brief introduction to the brand new Arduino Uno R4 Wi-Fi. I'm going to turn on some light here. Watch your eyes. So this is a whole new world in Arduino land. We have a 32-bit ARM core processor, 32-bit coprocessor with Wi-Fi and Bluetooth, built-in real-time clock, op amp. This is an entire electronics laboratory in the palm of your hand. This is $25. Prices will probably go up a few bucks once I publish this video. But let's say under $30 for just about everything you need to know to learn digital electronics. That is just awesome. You know what else is awesome? You guys. Thank you. This is my first video of 2024. We started this channel in 2016. Never thought I would be here. Certainly never thought I would earn that, the YouTube 100,000 subscriber award. But I am very proud of that. And I am very proud that you guys come to me for electronics advice and information. That's a sacred trust, and I do my best to do my best. All right, I'd like to thank the patrons for supporting me all these years. Without them, there would be nothing. And I'd like to thank you for watching, because if you didn't watch, why on earth would I be doing this? All right, guys, that's all I've got for you in this brand new year of 2024. I hope you enjoyed. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. I'm wishing you a great year, guys. That's it. I'm out.